All right, so in this video, we're going to be taking the real roots and even the complex roots. We're going to be taking the x-intercepts and we're going to be writing the equations in standard form from those x-intercepts. So we've done something similar in a previous assignment. In the previous assignment, we took the x-intercepts and we wrote the equation as its linear factorizations, and we stopped there. So we had the equation already drawn. We might have had drawings that looked like this, maybe something that looked like this. You can see multiplicity of 1, multiplicity of 2. Something like this. You can see all of these x-intercepts have a multiplicity of 1, and we would go through and we would write the x-intercepts and we would put the x-intercepts kind of back in that factored form. And that factored form, if you paid attention to the directions that day, it would say write the linear factorization of this equation. And so that's kind of the factored form. So let's go ahead and write this in our notes. This is the linear factorization. And it's always nice if that's what they ask for, because you can just write it in the factored form and then stop. But sometimes they're going to ask you to write this in the standard form of the equation, which means you write it in the parentheses and then you have to multiply everything out. You have to FOIL everything out. And when you do that, it's a little bit more work involved. So here, when they FOILed everything out, x times x is x squared. X times negative 4 is negative 4x, negative 2 times x is negative 2x, and then here's a typo, negative 2 times negative 4 is positive 8. And then they combined like terms and got x squared minus 6x plus 8 is the equation that represents that parabola, that quadratic. So this right here would be considered the standard form. Two different types of equations, the linear factorizations or the factored form, the standard form, both represent this picture, just two different ways of representing it. So here we have another scenario. This is a cubic equation. So here we have x-intercept at negative 1. Here we have an x-intercept at 3 with a multiplicity of 2. Remember, you can tell it has a multiplicity of 2 because it bounces right there at x equals 3. And then based on the end behavior, I can see that it would have a negative coefficient because the arrow goes up and then down. So overall, it's got a negative slope. So I went ahead and I started this by saying negative and then x plus 1 for the x-intercept of negative 1, and then x minus 3 squared for the x-intercept of positive 3 with a multiplicity of 2. So this is the problem written as a linear factorization. And we're always going to have to pay attention to the instructions now, because now sometimes they might write find the linear factorization, or they might say find the standard form, and we want to know which one it is. So here, if you're going to find the standard form, then you're going to want to write down your multiplicities. You're going to want to expand that out. So this multiplicity of 2, we wrote twice. And then when we wrote it twice, I went ahead and I took these parts right here and I FOILed them. So x times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is another negative 3x, and that makes negative 6x. Negative 3 times negative 3 is positive 9. And then over here, I'm leaving these two parts. Eventually, we'll deal with the negative in the front later. So what I did next is I took these two to multiply. And whenever I have 3 terms multiplied by something else, I don't FOIL in that situation. I always multiply with a box. And so you can see that's what I did next. So I did a 2 by 3 box because I have 2 terms multiplied by 3 terms. So x squared minus 6x plus 9, positive x and a positive 1. So x times x squared is x to the third. X times negative 6x is negative 6x squared. X times 9 is 9x. So you can see I did all that multiplication. And then I carried this negative down here. And then from the box, I had x to the third right here. And then I had I'm finding all the typos in these notes. And then I had a positive x squared right there. Positive x squared and negative 6x squared make negative 5x squared. Negative 6x and 9x give me 3x, and then 9 right there. And then at the end, all I had to go through is go through and take the negative and distribute the negative to each term. And then here was my final answer for what that cubic function was in the standard form. So here I'm going to write standard form. All right, so we have another function on this page where they haven't done the work, so we're going to go ahead and do the work for this problem. So we have 1, 2, 3, 4 x-intercepts. So I'm going to go ahead and write down what those are. I've got negative 5, negative 1, one, two, three, 3, and 4. And so what I'll do next is I'll write this as a linear factorization. So f of x equals x plus 5, x plus 1, x minus 3, x minus 4. And so now I'm going to go ahead and start multiplying. I can only multiply 2 sets of parentheses at a time. So I'm going to go ahead and I'm going to multiply these 2 and I'm going to multiply these 2. So I'm going to FOIL. I've got x times x is x squared. X times 1 is 1x. 5 times x is 5x. 5 times 1 is 5. So that gives me x squared plus 6x plus 5. Okay. Then over here, x times x is x squared. X times negative 4 is negative 4x. Negative 3 times x is negative 3x. Negative 3 times negative 4 is positive 12. So if I combine my like terms, that gives me x squared minus 7x plus 12. Okay, so at this point I have a trinomial multiplied by a trinomial. I'm going to go ahead and multiply these using a box because 3 terms by 3 terms, you can FOIL it, but it's really easy to make a mistake and miss some terms when you multiply. So I'm doing a 3 by 3 box. It doesn't matter which one you put on which side. So I'm putting this one along this side and this one I'll put along the other side. So x squared times x squared is x to the 4th. X squared times negative 7x is negative 7x to the 3rd. X squared times 12 is 12x squared. 6x times x squared is 6x to the 3rd. 6x times negative 7x is negative 42x squared. 6x times 12, 72x. I should double check that. I don't trust my mental math. 6 times 12, 72. Okay. 5 times x squared is 5x squared. 5 times negative 7x is negative 35x. And then 5 times 12 is 60. I happen to know that one off the top of my head. Okay, so now let's write our equation in standard form. We have f of x, and then the nice thing about multiplying using a box is that the like terms are on diagonals, so it makes it really easy to combine your like terms. Okay, so 6 and negative 7 makes negative 1, 5, negative 42, and 12. Negative 25. Negative 35 and 72 is 37, and then plus 60. So there is our standard form equation for this graph over here. And of course, if you wanted to make sure that you got the right answer at the end, you could graph this and make sure that the x-intercepts matched up the way they should have. Okay, we're not going to finish all the notes. We're just going to do one more problem. What kind of answers do I get when I solve for x with the quadratic formula? So we're going to go ahead and write the quadratic formula. It's negative b plus or minus square root b squared minus 4ac all divided by 2a. So the most important part of this with the quadratic formula is that the quadratic formula has a plus and a minus in here. So when we solve using the quadratic formula, we get two different types of answers. We get irrational answers. These are answers with square roots in them, which means that they give us funky decimal answers. We also get imaginary answers, which are answers where we have square rooted a negative number. So irrational answers, those are numbers that have been square rooted, and then imaginary answers. And the important thing about them is that they always have a plus minus with them because they came from the quadratic formula. So those answers always come in pairs. Those answers always come in pairs. So regular numbers, like the numbers we were seeing on the front, you could get a regular 5, you could get a -7, you could get a 2, you could get a -3.5. Those kind of nice answers, they come on their own because they come from factoring with solving. But answers like this example, square root 2, you're not going to see a square root 2 by itself. You're going to have to see a negative square root 2 as well. If you see an answer of positive 3i, you're also going to see an answer of negative 3i. If you see an answer of 6 plus 7i, you're also going to see an answer of 6 minus 7i. So all of these answers that have radicals in them or i's in them, they're always going to have the plus and the minus version because they came from the quadratic formula. So that's a really interesting thing about it. It's also kind of an interesting thing that they use in the problems. Instead of giving you both of the pair, like saying, oh, one of the roots is root 5 and the other root is negative root 5, they'll probably just give you one and they'll make you determine what the other one is. So let's go ahead and do this example, and then we'll leave the rest of the examples for class time tomorrow. So here we have an x-intercept of positive root 2. We have another x-intercept of negative root 2. So I'm going to say x equals root 2. X equals negative root 2. And so I'm going to go ahead and write the linear factorization for this. So if that's the positive, then it's going to be x minus root 2 in the parentheses. If that's the negative version, that's going to be plus root 2 in the parentheses. And I'm going to start to FOIL this out. Now, most of us would not see this as a linear factorization because they wouldn't leave a square root in a final answer like that. It just looks weird. It's not that it's impossible. They just wouldn't do it for the most part. So we're going to go ahead and FOIL this. X squared. And the nice thing about these problems is that they're going to look funky in the meantime, but by the time we get to the standard form of the answer, they are not going to look funky anymore. So x multiplied by root 2 is just root 2x. So it'll be fine. Negative root 2 times x is negative root 2x, and you might already be seeing what's happening here. Negative root 2 times positive root 2, I'll show you with the calculator, negative square root 2 times positive square root 2 is just negative 2. So if we look at this, we have a positive root 2x and a negative root 2x, and those canceled out. So we end up with x squared minus 2. So the nice thing about this is that while the roots are kind of funky and the parentheses, the factored form is kind of funky, by the time you get to the standard form, the problem has taken care of itself. It actually looks pretty nice in the standard form. And that is true for all of the answers that are a little bit uncomfortable. By the time you get to the standard form, they're going to look nice again. So this is the last example we have. We'll do the rest of them tomorrow.